Let me begin at the beginning. And the beginning, this is Amos Tversky. This is Amos Tversky as he was when he was in his 50s. I mean, this is a very distinguished gentleman, obviously an extremely smart scientist. But this is Amos Tversky as he was when the work was being done. And you can get from this a sense of the joy that was, that was part of doing the work. The picture that you just saw, the picture of the two of us, this is something that nobody, I think, could see, because I could feel it. Watching this picture, which I hadn't seen in many years, brought in a sort of motor memory of what it was like for me to be in Amos's presence. And for me, the motor memory was that I was completely focused on what he was saying. And he was focused on what I was saying. And when we were together, we really were not paying attention to most other things. It was an exceptional collaboration. It was a collaboration that both of us, I think, felt that we were just smarter together than either of us was individually. We dedicated the first 5 years of our work to the question of whether people are good intuitive statisticians. It started with a visit of Amos to a seminar that I gave where that issue arose, and he presented some work from the University of Michigan suggesting that people are good intuitive statisticians. I thought that was nonsense. This was Israel. There was a heated debate, as you can imagine. I think I won that debate. And Amos and I were off to the races, studying the question of whether we were good intuitive statisticians. And I say we because that was really our method. Our main method was to study our own intuitions. We would spend hours every day walking or sitting, having coffee, and talking. And much of the talk was talk about our own mistaken intuitions. And we would invent problems, and where we knew the correct answer, but the point was not the correct answer. The point was that we wanted somehow to give the wrong answer. And that was the main method of our research. Now, during those 5 years, we invented lots of problems, and I'll show you just a few. So this is one that's associated with the representativeness heuristic. And it's a story of Stephen, who is shy and withdrawn. And I mean, he's a stereotypical librarian. And the question is, Steve more likely to be a librarian or a farmer? The preamble was that he's been sampled at random. But actually, it doesn't make much difference. It's just to placate critics that we have that sentence. The point is that people really overwhelmingly and immediately feel he is a librarian. Now, and it was designed that way. He looks like a librarian. Now, there is another relevant fact that by and large nobody thinks about. And this is that in the United States, you may not know the exact number, but in the United States, there are about 20 times as many male farmers as there are male librarians. And that fact is highly relevant to the question of whether he's more likely. There are more shy people on tractors than there are in libraries. And so that's the base rate problem that people ignore. And it's one of many demonstrations of that. That's not representativeness, actually. That's another heuristic called availability. But consider the letter K in word of 3 letters or more. Is K more likely to appear in the first position or in the third position? Now, it turns out for every letter of the alphabet, people say that it's more likely to occur in the first position than in the third position, which is absurd, of course. It couldn't be true for every letter of the alphabet. And that is because it is simpler to find letters when you're searching for them in the first position than in the third position. Really very elementary. And it turns out this is an important way that people think or evaluate frequencies in their environment. And here is another one. Which is more likely? That a mother has blue eyes if her daughter has blue eyes, or that a daughter has blue eyes if her mother has blue eyes. And people have an immediate intuition, it's actually quite powerful, that you can predict the daughter better than the mother. But if you stop to think about it, the probabilities are precisely equal if the distribution of eye color is the same across generations. What happens is that people seem to favor reasoning along the causal flow. And when you reason along the causal flow, from the early to the late, or from the prominent to the less prominent, it's more comfortable, it flows easier. And when it flows easier, it looks more probable. So those were the kinds of problems that we invented. And you can see that it was fun to do. And what we were documenting were biases. And what I mean by bias is a type of error. It's a systematic error. It's a predictable error. So this is what we did. 5 years later, after we started in 1974, we published an article in Science magazine which reviewed the work that we had done. And that article had an impact across disciplines which was much, much larger than we had anticipated. In fact, we hadn't anticipated very much. But the article was very widely read, and it turns out to have been quite influential. It's still alive. People are still citing it quite a bit. And it was really pretty much lucky that it had so much impact. Part of the impact, and especially part of the impact across disciplines, was an issue of format. The way that Amos and I always presented our work, and it's something that I did as well in the book that I wrote, is we presented questions, such as these questions, in the body of the text. This was an idea that we'd adopted from books in perception. Everybody who's had, an introductory class in psychology has seen the chapter on Gestalt principles, or figure ground, or perceptual organization, and the illustrations are right there. So, and what that does is it turns you into your own subject. It identifies you with what is happening. This turns out to be especially important when what you're documenting are failures of thinking, because when you describe failures of thinking as results of experiments, the readers who themselves tend to be faculty and very clever and know that they're clever, they tend to think that those are just undergraduates making those mistakes. When they read those examples, they feel the intuition. They feel what Amos and I felt when we were inventing those problems, the temptation to make the same mistake. So that was one reason for the impact. It was really a choice of medium, purely accidental. The other reason was the message. And the message that was heard was much stronger than the message that we intended. We intended to describe how people deal with problems of thinking under uncertainty. The message that was heard was that people are not rational. And the reason that message was heard was that there exists in the social sciences, primarily in economics, but it's actually the most significant theory in the social sciences, is the so-called rational agent model, which assumes that agents who make decisions tend to be fully rational. And the definition of fully rational is extremely demanding. So what was surprising to us was that our article was received as if this is what it was saying, that people are not rational. And frequently it is said that people are irrational, and we are considered the prophets of irrationality. This really irritated us a lot, and I cringe when I hear the word irrational associated with my work. Whoops. Okay. But in the rational, later we took on the rational agent model, and we actually confronted it directly. And I think to some extent the work that we did does refute the rational agent model, but it doesn't prove that people are irrational. To give you an example, the rational agent model assumed that rationality of beliefs and of preferences is coherence, and by which is meant logical coherence. And so I can give you an example. How many murders are there in a year in Detroit? And how many murders are there in a year in Michigan? Now, for anybody who is reminded that Detroit is part of Michigan, the answer is obvious. You don't have to figure it out. There are bound to be more murders in Michigan than in Detroit. What is interesting is what happens when you present those problems to different individuals. in what psychologists call a between-subject design. And in a between-subject design, there are more murders in Detroit than there are in Michigan. And the reason is very straightforward. Detroit feels more dangerous than Michigan does. Michigan is a sort of pastoral state. It's associated with calm and so on. Detroit is not. And this is what people do. And so when people are asked that question, although they could reason if they saw both options, when they see only one option, they respond in a way that causes them to. It doesn't cause anybody to make a mistake because they don't have the opportunity to make a mistake, but it shows you that their judgments are not internally coherent. That if probed one at a time about Detroit and about Michigan, they would give answers. If they would forget the first question while answering the second, their answers would be internally inconsistent, would violate logic. The rational agent model not only says that people can reason properly about inclusion relations, such as Michigan including Detroit, but that people's individual beliefs are as consistent as if people had reasoned about them. And this is nonsense. This simply is something that a finite mind cannot do. Let me give you just another example before moving on. Some years ago, there was a lot of terrorism in Europe. American tourists were worried about it. And somebody asked them, Howard Kunruth, to be precise, asked people to evaluate insurance policies. And there was one insurance policy that offered $100,000 if during your trip you die for any reason. And the other policy offered $100,000 if during your trip you die in a terrorist incident. And the question is, which of these two policies is worth more? And the answer, clearly, the second one is worth a lot more than the first. That is, although obviously if you die in a terrorist incident, you die, and then there are many other more likely ways of dying, people don't answer that way because they don't answer in terms of Venn diagrams. They don't answer in terms of what is called extensional logic. What they do is they measure how afraid they are. And people are more afraid of dying in a terrorist incident than they're afraid of dying. And that is what causes this particular mistake. So you can see what is happening. We can reason logically, sometimes, not always, but when beliefs are probed one at a time, the beliefs probed one at a time are not logically coherent, are not logically consistent. Now, extensional logic is the kind of logic that we learn about in Venn diagrams. It's primarily really about inclusion of sets and about relationships among sets. Extensional logic also demands invariance. That is, that if there are two sets whose membership exactly overlaps, then those two sets have the same probability and they share many properties in common. Now, so that logic would demand that if you describe some cold meat as 90% fat-free or as 10% fat, that people would treat those two identically. Well, they don't. 90% fat-free is a lot more attractive than 10% fat. If you describe a medical procedure, surgery for lung cancer, as causing within the first month 10% mortality, or as being associated with 90% survival, people are much more likely, that includes physicians, to pick the surgery if it is described as 90% survival than as 10% mortality. Those are violations of really the fundamental assumptions of the rational agent model. So the rational agent model is false, but people are not irrational. Irrationality to me means something entirely different. It means sort of frothing at the mouth. This is not what people do. People are reasonable. And, as my friend Dick Thaler likes to say, people are human. And they reason like human, which is not stupidly, which is not irrationally. It's just different. It is not what the rational agent model prescribes. In fact, our intuitive thinking is also dominated by a kind of coherence, except it's a different kind of coherence. And I will call it associative or associative and emotional coherence. And the basic notion here is not entailment, or logical entailment, or implication. The basic notion here is a notion of fit. How well do things fit together? So this is a familiar example. You have those two pictures, and you have two words, Takiti and Maluma, and which word belongs to which picture? And nobody ever hesitates for a moment. It's absolutely obvious. There is a sense of fit, that one of these fits the other much, much better than if you inverted it. Now, that's a kind of coherence. That is, to take the rounded figure and to call it Maluma, there is a kind of coherence which is not logical coherence. It's a different kind of coherence. If I tell you that Hitler was very affectionate to children and to dogs, which, by the way, I believe is true. If I tell you this fact, it's uncomfortable. It is not a good fit. This was an evil man. Being affectionate to children and to dogs is a good thing. There is an emotional misfit. So associative and emotional coherence is absolutely the key to intuitive thinking. This is the property that intuitive thinking does respect. Whoops, I'm looking at the wrong place. Okay. Here is an example of, it's a familiar example of, you read these things as ABC, you read this thing as 12, 13, 14, but of course the B and the 13 are strictly identical. But we read in context, and in the context, it fits better. There is no implication, there is no logical requirement that this be so. But our perceptual system instantly goes for a coherent interpretation of this. Another example, also standard, is that Anne approached the bank. When you hear that sentence, most of us think of a financial institution. But in the context of fishing, that sentence has a completely different meaning. And what is interesting, we don't really entertain the alternative meaning. We entertain it possibly very, very briefly, and not consciously. Consciously, there's one meaning, and it suppresses the other. And that turns out to be extremely important. Here is another effect of context. So wash calls for soap, and eat calls for soup, and so on. The very best example of that phenomenon that we call priming is a personal one, which I will tell you about, and my wife doesn't like to hear about it because it involves her. Some time ago, after the book was written, otherwise it would have been in the book, Anne and I were visiting with a couple of friends, and later there's sort of pillow talk, comparing notes, and Anne says about the man, he is sexy. Okay, and the next thing that she says is absolutely bizarre. She says he doesn't undress the maid himself. Now that is very, very odd, and what on earth happened to my wife? I mean, he doesn't undress the maid himself. I say, Anne, what are you saying? How could you say a thing like that? And in fact, that's not what she said. She said he doesn't underestimate himself. And now, the point is, one word, one word changes the interpretation. And there are several important aspects of this particular example. One is that it never occurred to me that I might have misheard Anne. I knew what she had said. The only problem was, why would she say a crazy thing like that? That is very common. This assumption that we know what has been said, we know the facts, we do not question the facts. There's something that we know, and we go beyond it. And then, I don't want to claim too much for myself here, but this incident, I think, illustrates the essence of creativity. And what I mean by that is you have a spark that hits a prepared mind, and then you get a very unpredictable result. That is, the spark is the stimulus, the mind is prepared, and you get an interpretation that, nobody here saw it. It's not only me. That's how you hear it, and you don't think that he doesn't underestimate himself and he doesn't underestimate himself. Actually sound very similar. So, another aspect of coherence is that we're endowed with a powerful facility for analogy and metaphor. And this is going to come up today, I'm sure. My favorite example from the book, which is not an example that Amos and I did, but it illustrates something we did write about. I speak of a woman named Julie who is graduating from university. She's a graduating senior. And I'm going to tell you one fact about Julie, which is that she read fluently at age 4. And I'm going to ask you about her GPA. And this very striking thing here, I'm not going to spend too much time querying you. Let me venture that every one of you has a GPA in mind. And let me venture furthermore, because I'm pretty sure of it, all the GPAs are in a fairly narrow range. They're distinctly less than 4, distinctly above 3.2. We know roughly where they are. And in this case, we know exactly the process by which this occurs. You hear she read fluently at age 4, you get an impression of precocity. You get a sense of her intelligence. You get some sense, and it's graded. It's intense. It's fairly intense. Not as intense as it would be, if she read fluently at age 2 or at age 18 months. But it's high. It's up there. Then what you do, and that's a miraculous thing, you find the GPA that is as intense as that impression of precocity. And that's the GPA that comes to mind. You are absolutely not conscious of any part of this process. Maybe I may exaggerate. You're not very clear. This is not something that you choose to do. This is something that happens to you. And so here is a case where we have an intuition, we know how it's generated, and it is generated through a process of matching. Now, that process of matching is truly miraculous. It's really quite striking, because I can ask you what size hamburger matches a GPA of 2.3, and you can figure what size hamburger does it. I mean, this is not limited. Any two intensive dimensions can be matched with good agreement among members of the culture. And that, I think, is quite striking. And it's part of intuition. It happens without volition, without intent. So this ability to match across dimensions is key to a lot of what we do there. Now, Amos and I distinguish intuition from computation, but we actually did not have anything terribly insightful to say about the difference. And the reason is simply we missed the conceptual tools that became available sometime later. And the essential conceptual tool to understand the difference between intuition and computation is a distinction that was introduced a few years later by Schneider and Schifrin, I think primarily, and that's the intuition between automatic mental activities and controlled mental activities. Some mental activities happen on their own, and others we have a sense that they're controlled. And there are many differences between automatic and controlled. And crudely, intuitive thinking maps onto automatic, and computational thinking maps onto controlled. So in the book, I revisit this issue of intuitive thinking. And I distinguish between two very broad and heterogeneous classes of events that, properly speaking, should be called type 1 and type 2. Type 1 corresponds to fast thinking, type 2 corresponds to slow thinking. And then, for reasons that may come up later, I use the term system 1 and system 2 instead of type 1 and type 2. And I have a good psychological reason for that I'll talk about maybe later. So this is one way that thoughts come to mind. That's the automatic one. It doesn't even have to say equal. 2 plus 2, just that comes to mind. this lady is angry, and that comes to mind. You don't have to intend to do it. In fact, it's almost a passive experience. It is very much like the experience of detecting that her hair is dark. This is completely different, 17 times 4. I mean, by the way, we know intuitively, we immediately know a lot about this. We don't know the answer. We know that it's a multiplication problem. You may know whether you could do it in your head. You decide whether or not to try. You probably decided not to do. I mean, a lot happened. The answer is 408, but the main thing is this problem is qualitatively different from the other two. And it is basically that distinction that the book explores. Now, I'm taking here a position that not everyone agrees with, that there is no real difference between seeing and remembering, or between seeing and thinking. I see a lot of remembering and a lot of thinking in the seeing. That is, we see things as objects. We recognize them. And some people want to distinguish practice recognition from perception. Feels artificial to me. You see an angry face, as we did earlier, and it's not only that you're seeing it, you are making predictions about it. That is, you have an idea. You know, if this was associated with a recording, you have an idea of the tone of what she's going to say next, and a vague idea of the content of what she's going to say next. And it's clearly not nice, and there is something that you're prepared for. So the sharp boundary that I want to draw is between fast thinking and slow thinking, between fast thinking and reasoning, effortful reasoning. So system 1, the system that produces type 1 thoughts, what defines type 1 thoughts are that sense of automaticity, the sense that they're not intended, they happen. And sometimes, you know, people do not feel the authors of those thoughts that come to their mind. So if I mention the word mother, you have an emotional response. This is much more complicated. If someone hears an upper-class British male voice saying the sentence, "I have large tattoos all down my back," people are looking puzzled. Now, the brain responds with an indication of surprise within a little more than 1/3 of a second to that state of affairs. This is incredible. This means in order for that to happen, you have to, you know, the brain has to recognize that this is an upper-class British male. It has to evoke the stereotype of upper-class British males. It has to find that, you know, large tattoos down the back is not characteristic of these people. And then there was a person like that who belongs to that category who seems to have large tattoos down his back. There is an incongruity, surprise, and that surprise is detected within a fraction of a second. And by the way, system 2, attention, the effortful system, is immediately drawn into that. That's performance of a very high order. System 1, for a master chess player, really explains what happens to them. They just glance at the chess position and they can say white mates in 3 immediately. System 1 causes, you know, for master chess players, all the moves that occur to them are strong moves. Weak moves just don't occur to them. System 1 is the one that does the driving, except when you need attention. And so, for example, when you're making a left turn into traffic, it's system 2 doing it because you need effort. And system 2 is characterized by the fact that there is interference. We have a limited ability to exert effort, and because of that limited ability, you really cannot compute 17 times 24 while making a left turn into traffic. And you shouldn't try. So system 1 is involved in some forms of creativity. And to me, it is most obvious while watching tennis players or basketball players. There is real creativity there. And it's not that they're not focused, they're intensely focused on what they're doing, but it's also clear that they're not, thinking strategically. Things are happening to them. I mean, they find their arm moving in particular ways. And that is delivered courtesy of System 1. So if we summarize this, System 1, as I understand it, is where perception comes from. System 1 is the repository of world knowledge. System 1 is the repository of skills. System 1 is the source of creativity. And System 1 is also, incidentally, the source of many judgmental biases. But this is not the main characterization of System 1. So in that sense, the view of the work that Amos and I did as, sort of indicting human nature for lack of rationality is absolutely inappropriate. Because in fact, System 1 is much more, it is both flawed and marvelous, but at least to my mind, the marvels are more impressive than the flaws. System 2, the effortful system, is really quite different. It's the one that we normally, when we think about thinking, we think about System 2 thinking. We think about thinking that takes time and that takes effort. System 2 is involved in reading a map. It is active and it is deliberate. And when System 2 operations, when performing System 2 operations, most of us, we have the feeling that we are the author of these thoughts, that this is something that we're doing, as again, something that is happening to us. And it involves effort, and how do we know that it involves effort? We know it both by physiology, the pupil dilates in particular, and because activities that demand effort interfere with each other, which is why you can't make a left turn into traffic while performing a computation. But there is another function of System 2, which is extremely important, and this is quite different. And for some people, it would justify splitting System 2. And Keith Stanovich, who is the author of these terms, would now prefer splitting it. And that is a function of self-monitoring and self-control. And why do I lump reasoning and self-monitoring? Well, for the simple reason that self-monitoring demands attention. And you can interfere with self-control and with self-monitoring by loading memory. So when you just put 7 memories in people's digits and tell them, keep those in mind, you'll be tested later, and then you give them other tasks to perform, their performance on many tasks is profoundly altered by the fact that they have to retain those digits. Basically, their capacity is constrained, the power of System 2 is constrained, and activities that demand, including self-control. So people use more sexist language when they have 7 digits in their mind than when they don't, and there are a wide variety of other examples. So we are, when we think of who we are, we think we are System 2. But, I describe System 2 as, in my view of the mind, System 2 is a supporting actor who thinks that he's the hero. I mean, the real hero of the story, when you're thinking of how the mind works, ought to be System 1. And the metaphor I have for how those two work together is, I'm not sure it's such a, well, it's the best I have. It's the metaphor of a press room, of a room with journalists and an editor. And the editor is overworked, and the editor is lazy, and there are people writing stories, and they're putting it in front of the editor, and the editor has the task of endorsing or rejecting or asking for a modification or passing it on to another operation. And I think of System 2 as that lazy, overworked editor. But basically, the newspaper is written by System 1. The newspaper is written by those who generate the copy. And what mostly happens is that System 2 endorses the suggestions of System 1. So System 1 comes up with impressions and vague beliefs and vague intentions. Those are endorsed by system 2, which doesn't take very much effort, and then the system proceeds. Now, so that's, all of this is a more favorable view, I think, of intuition than would be suggested by our early work. Let me spend the remainder of my time on sort of trying to bring this together. There are some characteristics of System 1 that make it interesting, and those characteristics are in part very closely related to basic characteristics of perception. So, you know, everyone has seen this figure, but the important part of this figure is that at any one time, one of the interpretations suppresses the other. And it's this suppression of alternatives is, I think, a key to the function of the intuitive system generally. That is. And because of it, we live in a world that is simpler than the real world is. Because alternative interpretations tend, there is a suppression process and a winner takes all, or winner takes most. Whoops. I'm absolutely not in control of this. Here we go. That. Okay. Keeping two interpretations at once, keeping in general two ideas at once, seems to be a problem for System 2. It seems to demand attention. Choice demands attention. Whereas responding to stimuli that are present one at a time seems to be something that can be done effortlessly. Now, that tells us something about what subjective confidence is, and it tells us something about how a two-system mind knows things, or more precisely, thinks that it knows things. The subjective confidence in a rational system should be an opinion. It should be the opinion that you have about the quality of your own thoughts. So that's the subjective confidence you ought to have. This is not the way subjective confidence is generated. Subjective confidence is generated by a sense of fit. It is actually a measure of associative coherence. So when the interpretation that you have of the world makes sense, you have confidence in it. It's an internal measure, and it is a feeling, not a judgment. And so we can have very high confidence in opinions that are based on very, very poor evidence, even when we know that the evidence is poor, because it is the coherence of the information that determines confidence and not a judgment of its quality. Then there is the word no, which I think is a very interesting word. In language, there are two conditions for using the word no. One is that there should be no doubt, so that's what distinguishes knowledge from belief. And the other is what you know should be true. This is part of the definition of knowledge in the regular, in everyday language. Now, scientists think that, they have a handle on what it means to know, and it depends on evidence, and you have to be able to prove what you think you know to other scientists. But other people just don't agree with scientists on this issue. We do not have a monopoly on knowledge. And I would say that, the religious fanatics out there, they know. And they know no less than we scientists do. The sense of knowledge is very much the same. And so how do they know? Well, it turns out that the question might be, how do we know? Because the reason that I believe in science is basically that I believe in people who have told me scientific facts. And those are people I trust, and those are people I like, and those are my people. And so that's what makes me that science is my faith. But if I liked and trusted people who were telling me other things, I would believe and know other things. Knowing is simply having no alternatives. It is the absence of alternatives that determines knowledge. And knowing is more a state of system 1 than it is a conclusion of system 2. If we want to understand where the biases come from that Amos and I studied, they come from a variety of characteristics of system 1, but there is one that I want to develop in particular. And this is that the perceptual system is about individuals. It's about individual objects. And if you see a flock of birds, it is an object at that level. There is one thing that a perceptual system doesn't do, and it doesn't deal in a proper way with ensembles. So here you can look at that array of lines. This is a problem that's been studied by many, including my wife Anne. I think that's findings from hers. You see that for a fraction of a second, and you have the average length of those lines. So that is something we see. We're able to turn a collection of objects into a prototype if there is enough similarity between them instantly. It's effortless, and a very brief exposure is quite adequate for that. Now, there is something we cannot do. And this is, what is the total length of the lines? Now, if you stop to think of it, we could have a perceptual system that would give us total length. In fact, it would be normal to compute total length first and to take the average by division. That is not the way our system works. We do not generate that operation. And there is a deep reason for our failure to generate that operation. There is a whole class of operations of the same kind that we do not generate. I call them extensional operations. And what it involves is enumerating the members of the set and integrating over the range of the set. That is an extensional operation. And the total length of lines in that set is an extensional operation. It is not the only one. So probability is an extensional characteristic. So the probability of, say, dying during a trip is an event that includes the probability of dying in a terrorist incident. That's the logic of it, and that's the logic of probability that we think about. And if people are not able to perform extensional operations intuitively, they're going to have difficulty with probability. And they're going to do something else instead of assessing probability, really. Now, there are many, and it turns out that many of the problems that Amos and I discussed are of that kind. There are phenomena that we call phenomena of neglect. And the phenomena of neglect have to do with the neglect of the size or the extension of a set. So in that case, we get the average of a set of lines, and we're completely insensitive, by the way, in our ability to get the average of the lines to the number of lines. So extension is naturally neglected. The important characteristic is the characteristic of the prototype, of the average. So base rate tends to be neglected because it's extensional. Sample size tends to be neglected because it's extensional. And most of the phenomena that we dealt with are of that nature. You can get paradoxes when you neglect extension. So when you neglect extension, Detroit can have more murders than Michigan because Detroit is more dangerous than Michigan is. Danger is a non-extensional attribute, and we think non-extensionally, and that's what we do. Extensional thinking we're capable of, but it demands system 1. I will just mention, I have 20 seconds, I may take another 30. I will just mention that these phenomena are not restricted to the domain that Amos and I study, that is, to the domain of thinking under uncertainty. If you undergo a medical procedure and somebody asks you about the total pain that you experienced, you are going to be completely insensitive, actually, to the duration of the pain. So I'll show you one slide. It's my last. people had an unpleasant medical procedure. These days it's innocuous, but then when the experiment was run, it was quite painful, colonoscopy, and their pain ratings were obtained from them as they were going through the procedure, and then at the end they were asked about the total pain they had experienced. And the total pain was entirely determined by a weighted average of 2 moments, the peak pain and the pain at the end. The duration had nothing to do with it. So although you're asking for total pain, which logically should be an integral, that's not what you're getting. And there are phenomena, so this is not statistical, this is something else, and I could go on because there are many other examples of that general kind. So, to summarize in a few seconds, Amos and I started a project 45 years ago, and that project in some sense is still ongoing, but it has changed shape. That is, in what I wanted to emphasize today is that the view that the project, and even my book, is primarily about errors and about the irrationality of man, is, I think, the wrong view. And in fact, it would be more interesting, I think, to think about System 1 as the source of creativity, and to ask such questions, unanswered so far as I know. How might we test the intelligence of System 1? You know, if we viewed it positively and not negatively, what would that do? And this is my suggestion for future work. Thank you.